the advent of today's modern freeways, a lot of people are doing a considerable amount of high-speed driving in their everyday lives. Of course, during rush hour, and for that matter at any time, freeway driving can become bumper to bumper, stop and go within seconds. What I'm trying to say is that on the freeways, whoa power is just as important as go power. It's even more important for those emergencies that require heavy braking. The brakes are one of the most important safety devices on any vehicle, and if the brakes are working right, the driver can count on a safe, sure stop every time. This month, Paul is going to give Hank, his new assistant, the complete how it works story on the latest Chrysler brake systems, both drum and disc. Then he'll cover some diagnosis and service tips.
Before we go any further, Hank, let me explain exactly how the dual hydraulic brake system works. If you understand the fundamentals, it'll be easier to diagnose and correct brake problems. Let's start with a typical dual hydraulic drum brake system. The hydraulic circuit consists of the tandem master cylinder, the residual pressure valves, the hydraulic system safety switch, and the front and rear wheel cylinders and connecting lines.
You said tandem master cylinder. What do you mean by that?
It's one unit with two separate brake fluid reservoirs arranged one behind the other, with two pistons that operate in tandem in a single cylinder bore. It's a lot easier to keep things straight if you think of the rear piston as the primary piston, since it's actuated directly by the brake pedal or the power booster. In addition, the primary piston supplies hydraulic pressure to the front brakes, where most of the braking power is needed. It stands to reason, then, that the front piston is the secondary piston and supplies pressure to the rear brakes. Whereas the primary piston is operated mechanically, the secondary piston is operated hydraulically by the primary piston. So, actually, the secondary piston is what is known as a slave piston. And if you have any trouble remembering, the front and rear brake line fitting nuts are different sizes to prevent the chance of connecting a line to the wrong outlet. The outlets are also marked F and R to designate which set of brakes it serves. Here's what happens inside the master cylinder. Each piston has a return spring which moves each piston cup slightly to the rear of its compensating port. In addition to keeping the compensating ports uncovered, the return springs return the brake pedal.
You threw me there, Paul. What are compensating ports?
They're small passages between the reservoirs and the cylinder bore. What they do is allow pressure to compensate or equalize when the pistons are fully returned. When pumping the brakes, more than the normal amount of fluid is forced into the hydraulic system and builds up pressure. The pressure buildup could become great enough to prevent the brake shoes from returning. This could cause them to drag and generate more heat and pressure. On the other hand, when the brake pedal is released, the piston moves back far enough to uncover the compensating ports, and the fluid can flow back into the reservoir and relieve the excess pressure in the lines and wheel cylinders. After the system cools and contracts, fluid can flow back into the cylinder to maintain full volume for the next application. Any air bubbles in the cylinder will also be able to bleed into the reservoir. When the brakes are applied, the stiffer primary spring pushes the secondary piston forward, compressing the secondary spring slightly. The cup at the front of the secondary piston passes and closes off the secondary compensating port. Pressure in the secondary portion starts to build up. At the same time, the piston cup on the primary piston has closed off the primary compensating port. Since the fluid is now trapped in front of each piston, further pedal movement builds pressure in both the primary and secondary chambers. During normal operation, there is a hydraulic link between the primary and secondary pistons. As I mentioned before, the secondary piston is actually a slave piston, operated by pressure developed in the primary chamber. The piston cup at the rear of the secondary piston works as the closed end of the primary chamber. As long as the secondary piston is free to move forward, you can't build any more pressure in the primary than in the secondary chamber. As a result, operating pressures in both chambers are equal.
How is it possible to pump up the brakes when the pedal is low? Wouldn't that require additional fluid?
Yes, Hank. That's the job of the filler ports. Now, here's how they do it. If the brake pedal is pumped rapidly, the return springs in the master cylinder return the pistons quickly. At the other end, the brake shoe return springs return the wheel cylinder pistons a lot slower. What happens is the flow of the fluid from the wheel cylinders is delayed and can't match the fast return of the master cylinder pistons. As a result, the master cylinder pressure drops and becomes lower than the pressure in the reservoir. Fluid is forced out of the reservoir by atmospheric pressure through the filler port, through holes in the piston, and past the piston cup. These filler ports are necessary because the compensating ports aren't big enough to handle the volume of fluid needed to pump up the pedal. On drum brakes, residual pressure valves are located in both master cylinder outlets and also contribute to the action that permits pedal pump-up. However, their real purpose is to maintain a light pressure in the lines and in the wheel cylinders. When the brakes are released, fluid flows out of the wheel cylinders and back to the master cylinder. This unseats the residual pressure valves, which allow fluid to flow into the master cylinder. When fluid pressure drops to about 15 psi, the valve is seated and residual pressure is maintained.
Is the same master cylinder used for both the drum and disc brake systems?
No, Hank. The master cylinder used on the disc brake systems has larger reservoirs. There isn't any real reason for the secondary reservoir to be larger. However, the primary is a different story. The primary reservoir for the disc brakes is bigger because the disc brake pistons in the caliper are larger than drum brake pistons, and more fluid is required as the lining wears away. Naturally, larger pistons will require more fluid to operate them. But this fluid is contained in the piston bore, which is larger than that of drum brakes. The other difference in the disc brake master cylinders is that there is only one residual valve, and that valve must be in the secondary outlet at the front of the master cylinder. That's the one for the rear drum brakes. Residual pressure in the primary brake lines would make the disc brake shoes drag and wear out prematurely. That's because there are no brake shoe return springs with disc brakes.
I've got a pretty good idea how the master cylinder works during normal operation, but what happens when pressure is lost in either system?
I was just about to go into that, Hank. If pressure is lost in the front brakes, there will be very little hydraulic pressure to resist primary piston movement. The hydraulic link is broken and the primary piston will move forward until it bottoms against the secondary piston. The secondary piston is operated mechanically by the primary piston to apply the rear brakes. By the same principle, when pressure is lost in the rear brakes, hydraulic pressure in the primary chamber plus spring pressure pushes the secondary piston until it bottoms at the end of the cylinder bore. At that point, the primary piston begins to supply pressure for normal front brake application. Last but not least are the cover gasket and cover for the master cylinder. They are important because they provide an airtight seal and still allow the system to breathe. Here's how they do it. The diaphragm portions of the gasket expand or contract as the fluid pressure rises or falls. This is the first part of the breathing. However, the space between the diaphragms and the cover must be vented so that the diaphragm portions can do their job properly. Small vent grooves or drilled holes built into the master cylinder cover vent the space between the diaphragm cover and gasket.
Remember, it's as important for these vents to allow air in as it is to let it out. And speaking of grooves, I think that the needle is just about to the last one on this side of the record. If someone will please turn it, Paul will continue with the hydraulic system
safety switch applications. First, The drum brake system uses only the safety switch. It also functions as a T to the front wheel cylinders. Second, the fixed caliper disc brakes, which use the safety switch with a proportioning valve behind it. And as of the 1st of January, the new combination safety switch and proportioning valve. Fourth, the floating caliper disc brakes, which use the safety switch with a metering valve ahead of it. Fifth, the floating disc brakes that use all three, safety switch, metering valve, and proportioning valve. Of course, the later models will have the metering valve and combination switch and proportioning valve. Inside the switch, a barbell-shaped double-headed piston separates the front and rear brake hydraulic systems. Coil springs at both ends keep the piston centered as long as the pressure stays the same in both systems. If pressure is lost in either system, pressure from the other system pushes the piston off-center. When the piston moves far enough to touch the ground contact in the switch, the warning light ground circuit is completed and the light comes on. The front brake part of the switch has an inlet and two outlets. The rear brake part has an inlet but only one outlet. Different size tube connectors are used here, the same as the master cylinder, to prevent incorrect brake line connections. Incidentally...
Hold it, Paul. You'd better tell Hank that on the floating caliper disc brake applications, one of the outlets to the front brakes is plugged.
That's right, Hank, and I'll explain why later. Right now, let's talk about disc brakes. Chrysler Corporation presently offers two different disc brake systems, the fixed caliper disc brake system and the floating caliper disc brake system. Disc brakes require more brake shoe force than drum brakes to get the same amount of braking action. The proportional area of the front and rear brake pistons is such that equal pressure, front and rear, will produce balanced braking on normal applications. However, in a hard stop, disc brake piston force must be quite high to get proper braking action. Because rear tire traction is reduced by a weight shift, the rear brakes tend to lock up prematurely from a high-pressure application. On fixed caliper disc brakes, a proportioning valve with a spring-loaded sliding piston operates when the hydraulic pressure reaches a certain point to reduce the rear brake pressure. On light pedal applications, the valve simply lets brake fluid flow through it to the rear brakes. On hard brake applications, system pressure naturally climbs higher. Above 300 psi, the piston moves against spring pressure to reduce rear system pressure buildup by about 50%. This way, the valve provides a pressure difference to keep front and rear braking forces in balance.
Remember, the proportioning valve is used on the fixed caliper disc brakes and some floating caliper disc brake systems.
I'm puzzled about one thing. Where is the proportioning valve located?
It's located between the safety switch and the rear brakes. The floating caliper disc brakes require a metering valve, which is located between the safety switch and the front brakes. Speaking of the safety switch, that's why one of the outlets is plugged when used with a metering valve. The metering valve acts as a T for fluid distribution to the front brake calipers. The floating caliper disc brakes on full-sized cars are designed for excellent balance with the rear drum brakes. However, on shorter wheelbase cars, it is desirable to reduce front-wheel braking on icy or extremely slippery road conditions. The metering valve cuts off pressure to the front brakes in the 10 to 135 psi range.
Let me make sure I'm not confused. The proportioning valve reduces pressure to the rear brakes to minimize rear wheel skids on hard brake applications. The metering valve holds off pressure to the front brakes under light braking to minimize front wheel skids on icy or wet surfaces.
Right, Hank. Incidentally, the metering valve is serviced as an assembly, so you won't have to be concerned with repairing it. Speaking of service, I think that Paul has done a good job of explaining how proper hydraulic pressure is maintained to the wheel cylinders. I think now that he should tell us how to make sure the components are operating properly.
Okay, Tech. The quickest and easiest way to test the hydraulic system is still by pedal feel. A spongy pedal usually indicates a brake system that needs bleeding, but first check the master cylinder for fluid level. A firm pedal that gradually goes down under sustained pressure usually means that the master cylinder seals are bad, and it should be replaced or overhauled. However, first check all brake hoses and fittings closely. The reason is, you could be losing pressure at a loose or damaged fitting or through a pinhole or fine crack in the hose or tube. Actually, it's a good idea to inspect the brake lines and fittings any time you put a car in the air. If you have to overhaul the master cylinder, service manuals are the best source for complete instructions. If you replace or overhaul the master cylinder, be sure to bench bleed the master cylinder before you install it. When bleeding out the brake lines, the bleed screws must be fully opened. If you open the bleed screw less than one full turn, an orifice is formed which compresses trapped air to form tiny bubbles, which are very hard to eliminate.
Be extremely careful to keep the fluid level in both reservoirs up when bleeding. If it gets low, you'll pump air into the system and have to start all over again. And be sure you use Chrysler Parts brake fluid. It has a high boiling point required for safe brake operation and is compatible with rubber parts.
What if the proportioning valve acts up?
It can do one of two things: fail to reduce pressure to the rear brakes and lock them prematurely, or block off flow to the rear brakes. If this happens, and you use too much pedal pressure to stop, you might possibly lock the front brakes. To test the proportioning valve, install a gauge in the brake line between the master cylinder and proportioning valve. Install another gauge in the line at the output end of the valve. Have someone push on the brake pedal hard enough to get a master cylinder output of approximately 500 psi. While holding 500 psi master cylinder pressure, the gauge on the valve output should read between 350 and 400 psi. If pressure reading does not meet specifications, remove the valve and install a new one.
In the past, there has been more than one type of proportioning valve, so make sure that you replace the proportioning valve with the right type for the particular model you're working on. And as of the first of the year, the hydraulic system safety switch and proportioning valve have been combined into one unit. Don't let it throw you, though. They're still the same parts and work the same way, only they're both in one housing.
By the way, is there any way to test the safety switch?
Yes, but test the bulb first. Apply the parking brakes with the ignition on. One light does two jobs, so the bulb is proofed or tested every time the parking brake is applied with the ignition on. Then, have someone apply the brakes and watch the light while you momentarily open a front and then a rear bleeder screw. If the light doesn't come on, install a new switch. There's one very important thing to watch for if you have to install a new hydraulic system safety switch. Make sure you don't install one with the proportioning valve if there wasn't one there in the first place. If you do, you'll have two proportioning valves reducing pressure to the rear brakes, and you won't have any stopping power at the rear wheels. To quick check the metering valve, park the car and apply the brakes gently, motor running if equipped with power brakes. A very slight bump or change in pedal travel will be felt after about 1-inch travel if the valve is working right. This signals the opening of the valve. If you have a helper, have him apply the brakes as you watch the metering valve push rod. The rod should move into the valve slightly as the brakes are applied and move out of the valve as the brakes are released. Gravity bleeding is preferred on disc brake jobs, but if you use a pressure bleeder on a system with a metering valve, be sure to keep the metering valve open. That's because pressure bleeders are usually operated at about 30 psi, and this pressure will close the metering valve and shut off flow to the front brakes. Use tool C4121 to hold the push rod open while bleeding the brakes. On earlier models, hold it open by hand or tape it open. And don't forget to remove the tool or tape when you're through. If you happen to forget, full pressure will act on the diaphragm inside when the brakes are applied. This might rupture the diaphragm and result in a ruined metering valve and loss of fluid to the front brakes. While we're on the subject, if you replace any component or disconnect any line in the system, you'll have to bleed the brake system after you reconnect the lines. And a good way to avoid damaging the tube nuts and brass seats is to use regular tube nut wrenches.
Boy, we sure covered a lot of ground on the brake hydraulic system. I hope I can remember it all.
The best way for you technicians to remember it all is to read your reference books carefully and thoroughly. If you think Paul covered a lot of ground in this film, wait till you get into the reference book. See you next month when the words and hydraulics are flowing again, this time on Power Steering.